Good evening to all of you. Welcome you guys. Welcome you all. I think we are live. Yes. First of all, do comment whether the audio video is clear to everybody or not. Comment करके बोलिए. Audio video is clear to everybody. ठीक है. चलो आज का सेशन हम शुरू करेंगे. Right. And this is the second lecture on the optics. Previously, we have discussed the optics. Part 1 we have discussed. Now this is the second part. This part we are going to discuss some additional topics. Let us say here the mirrors analysis and the lenses के बारे में भी हम discuss करने वाले हैं. Right. And coming to this, the great news about the Unacademy. So we have started this AAI ATC batch हमने शुरू किया, and we started with this. All the top educators will take the classes. You can have a look at. And so this AAI batch, that is just 3,999 में आपको मिलेगा. You will get this is just 3,999 में आपको मिलेगा. So use the code BV ready to avail these great opportunities, and use the code BV ready so that you will have this Unacademy subscription just 3,999 में आपको मिलेगा. Right. And there are new batches we are starting. You can have a look at. And the new batches engineering maths is going to start by Vishal sir. And so the student who has taken the Unacademy subscription for them, you will get the test series भी आपको free में मिलेगा. You can see now here part test. Part test we have total number of tests. You can see this thing here 77. Part test are 29 and subject wise 10 and subject wise advanced levels 10, multi-subject, full-length mock test, PYQs. Total it is 77 test आपको मिलेगा. And Unacademy offers the Plus subscription as well as Iconic. Plus में आपको top educators का classes मिलेगा, live doubts and structured courses and PDF, live quiz and test tests, and unlimited access. You can access these classes any number of times. And Iconic में आपको क्या मिलेगा additionally? So physical notes भी मिलेगा इसके साथ 1-to-1 mentorship भी आपको मिलेगा. 1-to-1 mentorship. So guidance के लिए you can book your session and time slot and connect with your mentor. Hello, let's start our discussions. Yes. Now let's see this thing. Last class, how many topics we have completed, you can have a look at, and we'll continue the remaining things. ठीक है? All of you do like the session and share to all your friends. Like the sessions and share to all your friends. All these things has been completed. So this is the last topic. We have seen the mirrors formula. We have seen, tell me all of you. Mirrors formula. The mirrors formula, which is given as what you tell me now here, object. It is a relation between object distance, image distance, and focal length. You can have a look at now. The formula, it is given as 1 by f is equal to 1 by u plus 1 by v, where f is the what element of focal length and u is the object distance and v is the image distance. And so here, and while using this formula, you need to follow the standard sign conventions. Let's see what are the sign conventions we need to follow. Let's talk about the sign convention, what we use. The sign conventions, do remember whether it may be a convex mirror, convex or concave, all the distances must be measured from the pole. All the distances are measured by considering the pole as a origin. The pole means what element of midpoint. So here this is the standard notations we use for the mirrors. And so this line, the line which is passing the midpoint, this line which is called as a principal axis. This line is called as a principal axis and this point is called as a pole. And somewhere here we have a center. Somewhere here we have a center. Now all the distances are measured by considering the pole as origin. Pole as origin, we have to measure all the distances. And the distance measured in the direction of incident light are taken as a positive. Means now here for example we have taken this as something concave mirror like this. So let us consider there is some object lies somewhere here. This is an object. The light ray will come from the object, say निकलेगा, it will fall on the mirror. Now this light ray which will come from the object, it will move. Let us consider the light ray will falling on this one, on the mirror like this. Now you can see now here. So this arrow indicates this is the incident ray. Along the incident ray, the distances are taken as a positive. Along the incident ray, the distances are taken as a positive. So this direction, the distances, if we move now, these are taken as a positive. And opposite to incident ray taken as a negative. Opposite to incident ray taken as a negative. Now you see, here is an object. Now here along the incident ray, that's why which we have taken as a positive. Okay. Now all the distances while along the incident ray positive, opposite to incident ray taken as a negative. Next, what else you see this thing? And the heights measured upward. That means above the principal axis taken as a positive. Above the principal axis, upward direction if I move, that is a positive. And below the principal axis, those are taken as a negative. Above the principal axis positive, below the principal axis is negative. Okay. Done. And we have seen about the magnifications. Magnification. So magnification in case of a mirrors, which is given as what? Tell me now. This is lateral magnification, height of the image by height of the object. Height of the image by height of the object, which is given as minus V by U. V is what? Tell me now. V is the image distance. U is the object distance. That is a lateral magnification. And longitudinal magnification is the square of the lateral magnifications. Longitudinal magnification means it is the square that is given as length of image by length of object. Length of image by length of object. And whenever this has a magnification, if it is positive, that means what? Tell me. The nature of the image is a virtual upright. Upright is also called as a erect. If the magnification is negative, that means the image is a real inverted. The image is what nature? Real and inverted image. If this is magnitude of m is greater than 1, that means image is magnified. That means amplified. If it is less than 1, image is diminished. Means size is decreased. Okay. And we have taken some concave mirror. Right. So here if we have some object is there, let us consider here. Here is an object we have placed now here. Let us say this is AB, and this AB is the height of the object. Height of this object which is equal to AB. Then, so here how this AB now here height now tell me parallel to principal axis or perpendicular to principal axis, which is perpendicular to principal axis. Then what we can say now, this height of this image which is equal to m into height of this object. You can see now the dimension which is parallel. Otherwise, consider we have some object is like this. Some object is like this. Consider here like this. And let us say this is CD. CD, from here to here we have this object. This is the width. Now let us consider this width which is equal to something WO, if I call width of this object. How this part you tell me now here, that is parallel to principal axis. If it is parallel to principal axis, then that is width of the image which is equal to what, tell me? That is m squared times of width of the object. Width of this image. So if the height of this image, which is what, tell me now here, height of this image is a m times, but width is what, tell me now, m squared times. Width of this image is what, tell me, m squared times of width of the object. Problems are already given in the group I given, so to solve it now. Once you know the concept, then only you can able to solve the problems. To solve the problems, first of all you should know the basic concepts. Then only you can able to solve the problems. And in the today's class we will discuss only the theory only, and from next time onwards, next classes we will do the problems we can discuss. And problems are discussed separately in the special classes. Okay. Special classes or YouTube classes will continue next time onwards we'll do. And today, so for today we'll discuss completely theory of the ray optics. Next time we'll do the problems. Right. Completed this thing here. Next one. Another important thing is, and look at now here, first thing is, and try to do remember the things now here. They may ask the directly questions. For any mirror, the things you have to remember is the things you need to remember for any mirror. Here we have a pole. P is a pole, and thereafter we have a focus, and here we have a center C, and thereafter this is infinity. This is, and this side infinity, this thing minus infinity plus infinity. Okay, so you have to remember the things now here. So here pole is a mirror, midpoint of the mirror is a pole, next focus and the center. These three terms you need to remember. Yes, look at now here first of all and try to understand here one by one. So then if you understand, then it will become very easy. Logically try to remember. Consider, so we have the object we have placed at infinity. Object is infinity. Object is infinity. Then the image will be formed at the focus. If the object is infinity, where the image will formed at the infinity, at the focus. If the object is at infinite distance, image will formed at the focus. Yes, since the object is very long distance, the nature, it should be what we can say here, diminished image will form. It will form, the size of this image is what, tell me, diminished. So what we can say now here, this is highly diminished. What we can say, highly diminished. And so this is, we are talking about the concave mirror first of all. Concave mirror will form this as a real and inverted image. Real inverted image. Okay, so do remember, if the object is infinity, where the image will formed at the focus. Next, now you tell me now here what happens. As usual, we should remember the terms now here. And this is infinity, and here we have a center, and this is the focus, and this is the pole, and this is infinity. Now what we are doing now here, we are moving the object. Now let us say object is here. If the object will come to the in between from minus infinity to the center, so here what happens now here, if the object will move the right side and image will move the left side. If the object will move this direction, then image will move this direction. That means what happens now, object is shifted from here to here. That means the image will shift to here somewhere. That means where the image will form, you tell me, in between center and the focus. In between center and the focus, image will be formed. And the nature of this image, what we can say now here, that is real, inverted, and diminished image. Real, inverted, diminished image. Try to remember this thing. We'll get direct questions milega from these things. Right. Next. So here this is infinity and center and focus and pole. This is another infinity. Here you tell me now here. If this object is reached at the center, and the image also will reach at the center. If the object is at the center, image is also at the center only. And so how the image nature can be formed, you see this thing here, the image which is a real inverted. When here in this location, object and image both are overlapping. Both are overlapping means size of the object, size of the image both are same. So means what we can say now here? Yes, which is same as object. Same as object. Okay. Understood all of you this thing? Logically try to remember. If the object is at infinity, image is at focus. If the object will come to the infinity to the center, image will shift from center to focus. If the object is at the center, image is also at the center only. And the size is same as an object only. The size of the image exactly same as the size of the object. Okay. Next. Now let us say here in this case, infinity, and here is the center, and this is the focus, and this is the pole, and infinity. Here you tell me now here, if the object reaches to here, then what happened to the image? Yes, object is moving the right side, image will move the left side. So then image will form here. Okay, simply here the two fellows now here. So simply here, these two, one fellow coming, the other fellow will move like this, and these two will meet at one place. Where they will meet, these two fellows, at the center they will meet. And so then object will move this direction, image will move this directions. Okay. All of you understood this one? And the nature. So what happened, you tell me now here? The nature, since the object is near to the mirror, so that's why it will be magnified. So I can say the nature is what I know, real inverted only, real inverted and magnified image. Now can you tell me now, if the object will reaches to the focus, what happens? Can you tell me the object reaches to focus, what happened to image? Now tell me in this case. Earlier, if the object is at infinity, that means image is at focus. Now here, if the object is at focus, image will reach just to infinity. Then exchange the positions. So means now if the object is at infinity, we have seen previously. Now if the object will reach us to focus, if the object is at focus, the image will come at the infinity. They will exchange the positions. And what can be the nature of this image now here? This is a real inverted. Real inverted and highly magnified. Real inverted, highly magnified. Next. Another special case, this one. Now, if the object will reaches to here, then where the image will form now here. Now, this is the special case. The object is in between focus and the pole, and image will formed behind the mirror. Image will formed here. This is the special case. Now, what type of image here? This is a virtual erect, and diminished image. Sorry, virtual erect and magnified image. Virtual erect and magnified image. Right. This is a concave mirror. Concave mirror. Now let's talk about the convex mirror. Image formation by convex mirror. In convex mirror, we have only two cases are possible. Let us see those cases. Only two possibilities you can find. Here this is infinity and the center, and this is the focus, and here this is the pole, and this is infinity. So here tell me now, if the object is at infinity, where the image will form? Image is at focus. And what is the nature of this image? So convex mirror will forms only the what type of image it can able to form? Virtual diminished image will form. Virtual diminished image. So here this is when the object is very long distance. It will form the image nature is what? Virtual, erect and diminished. Here we have very long distance now, that's why we can say this as highly diminished. Highly diminished. Highly diminished image in this case. Now this is infinity C and this is focus P and infinity. Now, so other than this thing here, if the object is other than any location, so this is anywhere except infinity, then where the image will form? The image will form in all these cases. Image will form behind the mirror. Behind mirror. Behind the mirror, image will form. And the nature of this image is what? Tell me. Virtual, erect, and diminished. Virtual, erect, and diminished. See all these things once, everybody. Convex mirror. Hmm? Completed? Everybody? Done? And this thing only we wrote in the form of a tabular form, you can see. Whatever we have discussed, that we wrote in the tabular form. If the object is at infinity, where the image will form, you tell me? Where the image will form at the focus. And this is what type of mirror? Concave mirror. Concave mirror will form the real inverted image will form. If the object is in between infinity and the center of curvature, then then where will happens now? In between focus and center of curvature will be formed. Center. And so if the object is at the center, image is also at the center only. If it is in between center and focus, and this is what I'll mean now here, beyond, backside of center will form now. And if it is at focus, if the object is at focus, image will form at infinity. And if it is between pole and focus, then it will form the inside the mirror, the image will form. And this image is what type of image? Virtual, erect and magnified. So if you observe carefully, the concave mirror, what type of images can be able to form here, you can see. Now this real diminished image. It can form real diminished image. Real diminished image. And the other one is what, tell me? It can form this as what, tell me now here? Same size, real magnified image. Real magnified image. And what else now here? It can able to form the virtual and magnified image. Only these are the types of images can be formed by the concave mirror. So you see this thing here. What is the other type nature is missing here, you see? So real diminished, real magnified, virtual magnified. We should have other categories. What will be now? Virtual diminished image. But the concave mirror cannot form the virtual diminished image. Concave mirror cannot form the virtual diminished image. But convex mirror can do that. Convex mirror can form the virtual diminished image. Convex mirror can form what type of image? Virtual diminished image. Okay, convex mirror can do that one. Only the convex mirror can form the virtual diminished image. Only this kind of image will form. So here concave mirror can form all the three types of images, and convex mirror purpose is only virtual diminished image. You might be seeing the vehicle side mirrors. Side mirrors are there in a bike, car, and those are what type of mirrors, you tell me? Vehicle side mirrors. Those are what type of mirrors? Those are the convex mirrors. Those are what tell me? Convex mirrors. We need to see complete backside. We need to observe now. The image is the virtual and diminished image. Then only the complete background, backside part is visible. How many vehicles are coming and everything is visible clearly on the mirror. That is the backside. Side mirrors are what type of mirrors are? Convex mirrors. It will, where the image will form. Yes, inside the mirror you can see the image. And what type of image will form now here? Those are what tell me? Virtual image and diminished. That means size has decreased now. decreased image will form. Is this point clear to all of you? Done. Chalo. Next one here. Yes, that is about the mirrors we have seen. Next, we'll talk about the refraction of light. Till now, mirrors can do what? Tell me. Reflection will do. Now we are going to talk about refraction. What is the refraction means? What? Refraction of light. Refraction means what? Tell me now. Bending of light. When the light is basically, when the light traveling from one medium to another medium, let us say here, and so we have two mediums are there. Let us say this I am calling it as a medium 1, this I am calling it as medium 1, this is the second medium. The refractive index of this medium 1 I am calling it as a mu1, and the refractive index of this medium is mu2. And here this is a normal. Consider a ray of light which is incidenting like this, a ray of light which is falling at the junction. Now the light will reflect, this is called as a reflected ray, and the light will refract also, will bend. Actually this light ray want to go in this path, but because of the change of medium, light will get deviated. If we call this is the angle of incidence is I, this is the angle of reflection. Angle of reflection equal to angle of incidence only. Now here this total angle is what you tell me now? I. Total angle is I. This angle is what? Tell me now? R. This angle is R. Now this is then this angle, this small part of angle. This is called as a deviation. This is called as what? Deviation. So how much this deviation delta, which is given as what element of here? I minus R. This is the deviation. That is I minus R. This deviation is called as a refraction of light. Why we have a deviation can happen, that is bending of light will happen, that is because of the velocity change. So different mediums velocity of light is different. If the velocity of light is low, then we can call that as a denser medium. Velocity is high, that is called as a rarer medium. So here in the denser medium, velocity of light is low. In the rarer medium, velocity of light is high. And when the light ray get refracted, the most important thing here, so many times has been repeated this thing, that is frequency remains same. Frequency remains same. Do remember, frequency does not changes. Frequency and the phase does not changes. But what changes? Velocity of light will changes, as well as wavelength of light will changes. And another important property, light always bends towards the denser medium. Light will bend towards the denser medium. When the light traveling from the rarer medium to denser medium, it will bend what direction now? Towards the normal. This is the dotted line is there now. This is a normal. Light will bend towards a normal. When a light travels from denser to rarer, it will bend away from the normal. Okay. So here, what is a refractive index that we are going to see first. Refractive index, it is a measure of optical density of a medium. Refractive index is what? It is a measure of optical density of a medium. How the refractive index of a medium is defined? That is a ratio between the velocity of light in free space to velocity of light in a medium. And that is given as c the velocity of light in free space. This value 3 into 10 power 8 by v, and which is given as what, tell me, mu r into epsilon r. In general, mu r is 1, so that's why refractive index of a medium, and that is given as square root of epsilon r. What is epsilon r is called as a relative permittivity. Epsilon r is called as a relative permittivity. Relative permittivity, epsilon r is a. And the refractive index is high, then we can call that medium is a denser medium. Refractive index is low, then that is a rarer medium. Okay. And refractive denser medium velocity is low. Rarer medium velocity is high, as we have seen. And in general, velocity in any medium which is given as, which is equal v is equal to c by mu, where mu is a refractive index. And wavelength in a medium is given as what, tell me now here, lambda naught by mu. Lambda naught is what, tell me now, wavelength in the free space or vacuum. Lambda naught is a wavelength in the free space or maybe vacuum. Copied. So this complete PDF that will be shared in the group I will share, you don't worry. Complete PDF, understand the concept, the complete PDF I will share in the groups. Next, laws of refraction. Previously we have seen laws of reflection, now it is a laws of refraction. The first one is what, tell me now here, the incident ray, refracted ray and the normal at the point of incidence lie in the same plane. And the next one is, this is the incident ray I, this is the refracted ray R. This refractive index of this medium is mu1. This refractive index is mu2. This is a 1 and this is the second medium. What is the second law they are saying here? The product of refractive index of a medium and sine angle, which is remains constant. That's what they are saying here. If we talk about this incident ray, the refractive index of this medium is mu1. Angle made by this ray with the normal, which is how much, you tell me now, this is sine I, and which is equal to refractive index of this medium is mu2, second medium, into what we can say now, this is sine R, which is equal. This is the second law, and this law, which is also called it as a Snell's law. This is also called as a Snell's law. And from this, what I can say now, this is sine I by sine R, which is equal to what, tell me now here, mu2 by mu1. mu2 by mu1. Okay. Now, condition for no refraction. When there is no refractions, the first condition is if, tell me now here, I is equal to 0, what happens? If I equal to 0, what the equation Snell's law we have seen now? Mu1 into sine I, which is equal to what, tell me now? Mu2 into sine R. So you see this thing here, mu1 into sine I, sine 0 is what, tell me now? 0, and which is equal to mu2 into sine R now. So that means what we can say now, sine R, which is equal to 0, that means R is also 0 now. Then no refractions. Second case is what, tell me now here, if mu1 equal to mu2, then see what happened. So this is mu1 into sine I, which is equal to mu2 into sine R, equal to mu. If I say mu1 is equal to mu into sine I, which is equal to mu2 is also mu only in a sine R, mu will get cancelled, that is sine I, which is equal to sine R. When can happens now here? I must be equal to R. That means angle of incidence, angle of refractions both are equal. That means no deviation. So when can happens now? These conditions. Okay. Under this condition, under these conditions, there is no refraction. So when the incident ray strikes normally at the point of incidence, it does not deviate from its path. So then deviation is 0. And second scenario is what, refractive indices of two medias are equal. If the both refractive indices are equal, in that case also we don't have any deviation. Okay. Chalo. Next, total internal reflection. This is another important concept. TIR we used to call. Here, critical angle. What a critical angle means? What, tell me? The angle of incidence in the denser medium for which the angle of refraction in the rarer medium becomes 90 degrees is called critical angle. Critical angle will denote as a theta c, which is given as sine inverse of mu r. Mu r means rarer medium by mu d denser. Simply we can say the small by big. Small by sine inverse of small by big is called as a critical angle. Okay. If the angle of incidence, the denser medium is greater than the critical angle, then what happens? Then the light is sent back into the same medium. The light completely will move to the back. This phenomenon is called it as a total internal reflection. So we have seen this as a light ray. And for example, here this is a normal. Now consider here this light ray which is coming from here. Here this is the source is there. Light is coming from the source somewhere here. The light ray which is coming here, it is incidenting at this medium. Now here this is the angle of incidence. This is I. if this angle of incidence, if this I value which is greater than the critical angle, then the light does not enter into the second medium. This is the medium one, this is the second medium, and it will reflect back completely into the medium one only. The light will completely reflect back to the medium one only. This phenomenon is called as a total internal reflection. Okay. So, and conditions for the TIR. What are the conditions now? First condition is what? Tell me. Light should travel from the denser to rarer. Keep in mind, denser medium to rarer medium. And other condition is what? Tell me now here. Angle of incidence must be greater than the critical angle. That what? That is, I must be greater than theta c. If these two conditions are satisfied, then only we have a TIR can happens. Okay. Opinion everybody? Chalo. As I have seen the previous year papers of ATC, they given problems on mirrors they given, and TIR this concept also given some problems. They given problems on the refraction of light also given. So these things you have to be properly plan it. The another topic is lenses. Lenses. See this thing here, lenses. The lens is also what I hear. Lens is nothing but what? Tell me. It is also made up of some transparent material. It should have a more than one refracting surface. It has more than one refracting surface. In this, at least one must be a curved surface. And we have different type of lenses we can see. The first category we used to call it as what? Tell me now here. Convex lens. This is a convex lens. This is a convex lens. And this is a concave lens. If the middle is thick, middle part is thick, edges is narrow, that is a convex. And the middle part is thin, edges is wide, then that is concave lens. Okay? Yeah. Here also. For convex lens, focal length, focal length for concave lens, focal length negative, similar to the mirror, focal length negative. Convex lens converges the light. So, convex lens is also called as converging lens. Concave lens diverges the light. Concave lens is also called diverging lens. Okay. Convex lens is called as a converging lens. Concave lens is called as a diverging lens. Everybody, these theoretical questions are very important. So you can get the problems on this. इस theoretical questions में मिलेगा problem. ठीक है. Earlier we have seen the mirrors formula, but here it is a lens formula. We want to find the image distance. So because of the lenses, we have to use the lens formula. We have to use the lens formula. 1 by f is equal to 1 by v minus 1 by u. So in case of a mirrors formula, we have 1 by f is equal to 1 by v plus 1 by u. Plus is there. But here we have a minus sign. But here we have this is a minus sign. And for convex lens, focal length is positive as I told. And for concave lens, focal length is negative. For concave lens, focal length is negative. Yes, copied all of you. And here also we have to use the sign convention. Sign convention is the same as a previous sign convention we have used. Mirrors, we have used the sign convention. Exactly same conventions are valid in this case also. Okay. Magnification. Previously, the magnification, which is defined as what element of height of image by height of object, same thing here. But in the mirrors, we have a minus sign is there here. But here the lenses, there is no minus sign. That you need to observe. Lateral magnification is given as what element of height of image by height of object, which is given as what element of v by u. Object image distance by object distance. And longitudinal magnification, which is the square of the lateral magnifications. If this m is positive, same as earlier, the image is the virtual erect or upright. If the m is negative, that is real inverted image. If the magnitude of m is greater than 1, that is image is magnified in nature. If it is magnitude of m is less than 1, image is diminished. Yes. All of you do copy these things, everybody. And do like the session and share to all your friends. and we shared the DPP of the ray optics. This optics we have shared in the group. I hope all of you got this. All of you received the DPP. Huh? Hmm? Everybody seen the DPP? Hmm. So the DPP, हर problem का solution will do. Will solve all the problems will be solved, and these problems we have prepared exactly according to the previous papers. By observing the previous papers, I have prepared the DPP. Okay, if we can able to refer those PYQs and all the PYQs also added in the DPP. Okay, yes. Copied all these things now, everybody. And that's it for today's session. And the next session we'll practice the problems on this optics. Okay, the DPP problems we'll practice, and we'll meet in the next sessions with the next topics. Okay, then see you. Bye bye. Have a great day. So do practice this thing, and the complete PDF which will be available in the group में आपको available होगा. See you. Bye bye. Good night. All of you do like the session first of all. Like the session, share to all your friends. Do like the session.